before taking that organic chemistry exams or that your chemistry exams, I want to quickly help you on everything you need to understand in organic chemistry, so that organic chemistry will be the easiest of your parts of chemistry. Don't forget, for those joining me for the first time, this is Dr. Best, and we are on Exclusive Tutorials YouTube channel. Now we're going to look at organic chemistry. I'm going to look at these things, other organic chemistry, type of bond, number of bonds, type of bonds, saturated and unsaturated compounds, carbon-carbon bonds. The another carbon-carbon bonds, we'll look at bond length, bond strength, bond type, hybridization, formal charge, bonding and non-bonding electrons, homologous series, distinguishing factors, and isolation and purification of organic compounds. Now let's just dive straight into organic chemistry. Now when we are talking about organic chemistry, what is organic chemistry? So organic chemistry is the chemistry of carbon and its compounds. So organic chemistry is simply the chemistry of carbon and its compound. But when we are discussing organic chemistry, there are some exceptions that you should know. Oxides are not part of it. Carbamates are not part of it, and carbides. So when we are discussing organic chemistry, the compounds that are exempted are carbon oxide, carbon carbamate, carbon oxide, carbon carbamate, and carbon carbides. So that is to let you know that when we are talking about organic chemistry, compounds like carbon 4 oxide or carbon monoxide are exempted. Now there's something I want us to look at shortly, is number of bonds, which is our first talking point on that part. Number of bonds. Now I want us to take look at elements. Now the reason why we need to take note of number of bonds is that when talking about organic chemistry, we are going to deal with a lot of structures. So for you to know the right way to arrange your structures, you need to know the number of bonds that a particular element accepts. Now first of all, you know, when we are talking about organic chemistry, we are concerned about carbon. But we are not just going to look into carbon, because we have other elements that bonds to carbon. So in as much as that, we are going to use this opportunity to look at the number of bonds that is being contained by all the elements in the periodic table by using a representative of the 8 groups that we have. Now we have group 1 elements, let's say hydrogen, we're taking beryllium, we're taking boron, we're taking carbon, we are taking nitrogen, we are taking oxygen, we are taking fluorine. Now remember, this is your group 1 element, this is your group 2, group 3, group 4, group 5, group 6, group 7. So all elements are here represented, right? Now group 1 elements are elements with +1, example hydrogen. Group 2 elements are elements with +2, example beryllium. Boron is +3, carbon is a group 4. This is nitrogen, group 5 with a valence electron of -3. Oxygen is group 6, a valence electron of -2. Fluorine is group 7 with a valence electron of -1. Now group 1 element hydrogen accept 1 bond. Listen, these 2 bonds, these 3 bonds. Carbon, remember our major focus when we are talking about organic chemistry is carbon. Carbon accepts 4 bonds, nitrogen accepts 3 bonds, oxygen accepts 2, while fluorine accepts 1. Now why are we looking at this? Let's say for example you are given a compound and they say you should bring out the level structure of the compound, or you want to name the compound. An idea of the number of bonds that a particular element forms is going to help you to do this. Now let's say for example I give you this compound CH32 CO, follow me, no, let's say CH, then let's say CH2, now let's say CH3. Now, how do you write the level structure of this compound? We're going to start with this. Having a complete idea or a full idea that carbon, which we are talking about, accepts one bond. Hydrogen accepts carbon accepts 4 bonds. Hydrogen accepts 1 bond. This will help you to arrange this thing correctly. Now, what do we do here? Know fully well that this is a compound and you need to arrange it. Now, look at this. This carbon is having just 1 hydrogen. It's having 1 hydrogen left because it has used up 3 bonds to bond to other compounds or other elements, which is to say that indirectly this carbon is bonding to this 2 compound. That means the methane here is 2, then this carbon is bonding to 2 of them, and at the same time bonding to this. Now, when we carry out this thing that we have said in our head, it means that this is the structure of this compound. Let's say, for example, we are bringing this hydrogen at it here. This 2 methane compound, CH3, CH3, bonding to this C, which means that there is a H here, there is a H here, there is a H here, which means this one is bonding to this C, H, 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 or you can just say CH3. So by having an idea of this, we have been able to know that we have been able to bring out the level structure of this particular organic compound. Now let's look at another compound as well. Now let's look at this other compound. Let's say, for example, we'll have a CH3 and we'll have a CO and we'll have a CH2. Should we bring in any other compound here? A CH2. We'll have a CH, NH2. And a CH3. Now, you are asked to bring out the level structure of this compound. How do you achieve this? Remember what we saw here. This knowledge here is also what you need, or is also what's going to help you to achieve this. Now, let's go ahead. We know that this is a carbon compound. And it has 4 bonds. The number of bonds carbon can contain is 4. The number of bonds oxygen can contain is 2. So for example, when we have this methane group bonding to this carbon. So we start by bringing out this carbon. Remember, there is no hydrogen bonding to this carbon, which means this carbon has used up 4 bonds in this compound. So we start with this CH3. Now, you cannot put in your oxygen here and say like this. If you say like this carbon has succeeded only in having just 2 bonds, which means this compound will not be correct. And remember that oxygen accepts 2 bonds, and there's another carbon here, which means that this carbon is directly bonded to this compound, oxygen, and at the same time this. So what do we do here? You first put in this carbon here, which means that this compound carbon is bonded to this oxygen like this. We call this a carboxy group, right? So oxygen has succeeded in collecting its 2 bonds, and this one comes in. So what we have here is is this carbon bonding to this hydrogen, bonding to this hydrogen. So we are done with here. Now here there is another carbon compound that is having just 1 hydrogen, and we know fully well that nitrogen accepts 3 bonds, and there is another carbon here, which is to say that this carbon here is directly bonded to this nitrogen, and at the same time directly bonded to this carbon. Now this nitrogen is supposed to accept 3 bonds, but we are having 2 hydrogen here. It means that it has used 1 to form a bond, so which means this nitrogen is here like this, NH2, and this is here like this. Remember, this one has just one hydrogen. You put in your hydrogen here. So you have been able to, by the knowledge of the number of bonds a particular element forms, to bring out the level structure of this compound. Remember, we have not gotten to what do we call it? The groups that are formed. This is a carboxyl group, and this is an amino group. We call this a primary amine, but when we go there, we are going to explain this. But I know with this, I've been able to understand the concept of number of bonds. Now we're going to look at types of bond, the type of bond in an organic compound. Now we have a lot of bonding types. When we talk about chemical bonding, we'll have your electrovalent bonding, we'll have your covalent bonding, we'll have your hydrogen bonding, dative bonding, and the rest. But in organic compound, we are going to look at covalent bonding. Covalent bond. Now, all organic compound undergoes what we call covalent bond. Now, what's a covalent bond? A covalent bond is a type of bond in which there is share of electrons. There is share electron between the two bonding atoms. Now, we have two types of covalent bond. We'll have your polar and we'll have non-polar. Now, when is a bond said to be polar covalent, and when is a bond said to be non-polar covalent? Polar covalent, when the electronegativity difference between the two bonding atoms is greater than 0.5 or greater than or equals to 0.5. While a bond is said to be non-polar covalent, when the electronegativity difference is less than 0.5. Now let's say, for example, let's say I give you a bond between carbon and hydrogen, and I give you a bond between carbon and fluorine, and I ask you, which of these is a polar covalent bond and which of these is a non-polar covalent bond? Now, with the knowledge of this electronegativity difference being greater than or equals to 0.5 or less than 0.5, you should be able to tell me which is polar and which is non-polar. Now let's look at this. The electronegativity value of carbon is 2.5, while that of hydrogen is 2.1. 2.5 minus 2.1 gives us 0.4, which means the bond between carbon and hydrogen is non-polar. This, just like we said, is 2.5, while that of fluorine is 4.0. The difference between 2.5 and 4.0 is 1.5. So the bond between carbon and fluorine is polar covalent. Remember the one we call hydrocarbons, a compound that contains hydrogen and carbons, which is to let you know that all hydrocarbons forms a non-polar bond. Repeat, all hydrocarbon forms a non-polar bond. So by the time you see elements or atoms bonding together, you should be able to tell whether in organic chemistry, you should be able to tell if this is a polar bond or a non-polar bond. Now let's proceed further. The next thing we are going to be looking at is saturated and unsaturated compounds. Now, when do we say a compound is saturated? Let's say, for example, an organic compound. This is carbon. When do we say a compound is saturated? A compound is said to be saturated when it contains the maximum number of hydrogen atoms that is supposed to be attached to it. The required maximum number of hydrogen atoms attached to the carbon. Now, we have three main types of organic compounds. We have your alkane, we'll have your alkene, and we'll have your alkyne. Don't forget, it's exquisite tutorials and it's just the best. Ensure you follow up with all our YouTube videos for all your preparations, and we're going to help you. By now, I'm sure every one of you that is watching this video must have subscribed to this channel. If you have not, come on, subscribe and share this video, right? Okay, now, but I hope you enjoy my class. Take some drinks and follow up. Now, an alkane is a compound that has the maximum number of hydrogen atoms bonded to the carbon. Now, this is an alkane. There's hydrogen here, there's hydrogen here, there's hydrogen here, there's hydrogen here. This is the first member of the alkane family. We'll call it methane. So, since it has the maximum number of hydrogen bonds attached to it, or hydrogen atoms attached to it, it means this is saturated. I know you have not learned the way I'm teaching you today. Enjoy. That is why we are the best, and that is why you are online with Dr. Best. Now, this is an alkene. An alkene begins with the first group, ethene. This is an ethene. Oh, sorry. So you are going to have hydrogen here, hydrogen here. Remember your knowledge on number of bonds. There's already two bonds. So this does not have the maximum number of carbon hydrogen atoms attached to the carbon, because there could be another hydrogen here, there could be another hydrogen here, but because of these two bonds here, the maximum number of hydrogen atoms that is supposed to be attached is not there. So we said this is unsaturated. Unsaturated. Now let's go again to the alkyne group, right? This is an alkyne, C. So you only have H, you only have H. So this does not have the maximum number of hydrogen atoms, because there could be hydrogen here. So this as well is said to be unsaturated. So when we are talking about saturation, we are talking about the maximum number of hydrogen atoms that is attached to an organic compound. So now let's look into carbon bonds. It's becoming interesting, right? So you're enjoying it? Yeah. Let's proceed. Now, going straight to carbon bonds. If you are hungry, you should take a quick break and take some popcorn, enjoy yourself, and come back. And when you do that, please share this video, like and follow, subscribe to the YouTube channel. You can also follow Dr. Best on my own personal page at Dr. Best on all social media platforms. Now let's look at this. Carbon bonds. Just like I told you, we'll have this single bond, double bond. So I think I should use red to indicate these bonds, right? Yeah, because we're going to be looking at so many things under carbon bonds. We're going to be looking at bond strength, bond length, and bond type. Now let's begin with length. Carbon bond, the order of bond length is this way. It means that single bond has the highest bond length, followed by double bond, followed by triple bonds. So the bond length is in this order: single, double, triple. So this bond is longer than this bond, while this bond is longer than this bond. That's all when we talk about bond length. Now let's go to strength. Talking about bond strength is in this order. Take note. Triple bond is stronger than double bond. Double bond is stronger than single bond. Why? Why is it so? It is easier to break just one bond than for you to break two bonds. And it's easier to break two bonds than for you to break three bonds. So, with your common sense, you should know that this is more stable. A compound that has triple bond is more stable than this, is more stable than this. So this can easily be broken than this, which means this bond can easily go into reaction than this. So when it comes to strength, triple bond is the strongest. Now let's talk about bond type. Now, when we talk about bond types, there's what we call sigma and a pi bond. There's what we call a sigma bond and a pi bond. Now, for a single bond contains one sigma bond. One. A double bond contains one sigma, one pi bond. A triple bond contains one sigma, two pi bonds. Take note of it. A single bond contains just a sigma bond. A double bond contains one sigma and one pi bond. A triple bond contains one sigma and two pi bonds. Now let's take a question from here, from bond type. Let me give you a certain compound, and I will ask you to tell me how many sigma and how many pi bonds are present in this compound. Let's look at this compound. Okay, C bam pam pam H H H H. Oh wow. C double bond C. There should be H here. 1 1 1 H H H. Now tell me, how many sigma bonds and how many pi bonds are present in this compound? Remember that we said one single bond contains one sigma bond and a double bond contains a sigma and a pi bond. Now let's count. How many single bonds do we have here? 1 2 3 4 5 6 7 8, which means first we have 8 sigma bonds. 8 sigma from the single bonds, right? Remember that we also said that a double bond contains one sigma and one pi bond. 8 plus 1 is equals to 9 sigma bond. And there is a double bond, 1 pi bond, which means this compound contains 9 sigma and 1 pi bond. Get it? 1 2 3 4 5 6 7 8 plus 1 here, 9 sigma bond, 1 pi bond. What if I asked you, what if I change the compound? I'm not going to answer this. You are going to answer it and drop the answer on the comment section. What if I change the compound to this? Something like this. Something like this. CH3. What are you going to get? Remember the number of single bonds we have here. Remember the number of double bonds, and remember the number of triple bonds we have here. Drop the comments, the numbers on the comment section, and let's see if you get it. I normally do give away in my class. The first person to comment this, you're going to win an egg time. Just drop comment and just drop a comment. I will look into your comment and say who gets it. Now let's look into something else. Let's look into hybridization. Hi, hope you're enjoying this class. Hybridization. Whenever I teach, you should be happy attending my class, and my class should be the best, because don't forget, I'm the happiest man alive. Let's go on a short break. We'll come back and continue with hybridization. Welcome back from that short break. Now let's look at the next topic, hybridization. Now when we talk about hybridization, what do we mean? Now remember, we're still talking about our alkane, double bond, and triple bond. Now we'll say that all alkanes, this represents alkanes, this represents alkene, and this represents alkyne. Now we'll say that all alkanes are sp3 hybridized, all alkenes are sp2 hybridized, all alkynes are sp hybridized. Now, how do we determine the number of hybrid orbitals or the hybridization of this element? Now, when we're talking about hybridization, one thing that I want you to understand, that hybridization talks about the number of atoms. You can get the hybridization by the number of atoms that is bonded to that particular element. Now, let's say, for example, you know that alkanes have 4 bonding atoms. No, in an alkane, the carbon bonds to 4 atoms, 4 hydrogen atoms. It has the complete atoms, right? So we have 1, 2, 3, 4. So S1, P3. Here we are going to have 1, 2, 3 possible electrons or possible elements that it can bond to. So we are going to have 3 here. 1, 2, 3. Having S, P2, 1, 2, 3. Here, carbon here can bond to 2 possible atoms. One from this side, one from this side, which is 2, which is XP. Now, still on hybridization, we have different shape of each hybrid orbitals in the shape of our hybrid orbitals. And we say that all sp3 hybrid orbitals are tetrahedral. Tetrahedral in shape. So here we are talking about shape. And we say that all sp2 hybrid orbitals are trigonal planar. Trigonal planar. While sp is linear or diagonal. Now, what are the bond angles? What are the bond angles? Bond angle. Now, all tetrahedral or sp3 hybridized orbitals have a bond angle of 109.5 degrees, sp2 120 degrees, while sp 180 degrees. So I talked about all alkanes are sp3 hybridized, and their shape is tetrahedral shape. Their bond angle is 109.5. Alkane, sp2 hybridized, trigonal planar, 120 degrees. Alkynes, sp hybridized, linear diagonal, 180 degrees. Now, let me say, for example, I ask us to determine the hybridization between a bond and not just an atom or an element in a compound. How do you determine the hybridization between a bond? Now, let's say, for example, this is a compound, hydrogen, hydrogen, right? And I ask you to determine the hybridization between this bond, the bond between hydrogen and carbon. How do you determine it? Just like I made us understand that hybridization talk about the number of atoms that is bonded to that particular compound, and as well the lone pairs. Now we have This is an alkane, and we'll have it to the carbon here, carbon in an alkane to be sp3 hybridized. Now, what you do is you determine the hybridization of the two atoms or the two elements. This is carbon in an alkane that is sp3 hybridized. This is hydrogen. The number of atoms it can bond to is 1. You put a dot this, so which means this is X. So the hybridization of this bond in this compound is sp3.s hybridized. As simple as that. Now let's look into something else. Let's look into formal charge. How do you determine the formal charge of an element in a compound? Formal charge. Now let's say we have a compound like this. Let's say we have a compound like this, and first of all you are asked to determine the formal charge of sulfur in this compound. Here is the formula to determine formal charge. Fc, formal charge, is equals to number of valence electrons minus number of bond plus number of dots. Now, the valence electron of sulfur is 6. So the valence electron of sulfur is 6. It will not be 6 minus number of bond here is 1. Number of dot here is 5. 1 plus 4, which is 5, minus 1, which is equals to minus 6 minus 5, 1. So the formal charge of sulfur in this compound is plus 1. Now let's say, for example, now we have what we call a carbocation, a carbon ion, and a radical or a neutral carbon. Now let's say, let me write them out. Carbocation, carbocation, carbon ion, and a neutral carbon. Now, a carbocation is a carbon that has a positive formal charge from the word cation. A carbon ion is one that has a negative formal charge, and a neutral or a radical carbon is the one that does not have whose formal charge is neutral. Now let's look at some examples here, right? Now let's say we are asked to determine the formal charge. If we're asked to determine the formal charge of this particular carbon, what is the formal charge of this carbon? Now we made us to understand that formal charge is equals to number of electron minus number of electron minus bond Fc is equals to E minus B dot Bd. The number of electron of carbon here is 4, right? Minus bonds 1, 2, 3, 4 minus 4. So the formal charge is equals to 0. So this carbon is neutral. How about we talk about this carbon? The number of electron here is still 4. The number of bond is 1, 2, 3. 3. There is no dot here. So this carbon will be 1 plus 1. So this carbon here is a carbocation. So it's going to have a partial positive charge. So it can accept an electron, right? Now let's say, for example, we'll have 2 dots here. What's it going to get? What will become the formal charge of this carbon? Still same way we'll find it. Number of electron is 4. Number of bond is 3. Number of dots is 2. So this will give us minus 1. So this will give us a carbanion. So this particular carbon here with this double dot will have a partial negative charge, which means it can accept a positive, it can accept a cation. So that is all for formal charge. Now, the next thing we're going to look into is bonding and non-bonding electrons. Now, when we talk about bonding and non-bonding electrons, we are talking about the number of electrons in a particular compound that is involved in a bond and the number of electrons that is not involved in a bond. Now, let's say, for example, we have a compound like this, C and C. No, let's just use something simple. H, 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 bonding to sulfur, and this O4 is like this. Now, let me explain something to you. Each bond, each single bond here, single bond represent 2 bonding electrons. Two bonding electrons. While each lone pair is equals to a pair of non-bonding electrons. A pair of non-bonding electrons. Now, let's say, for example, remember sulfur here. If I have to determine the formal charge of sulfur in this compound, remember sulfur here has a valence electron of +6, right? 2 electrons have formed one bond to form this. So that's why you are having 2 pairs of two lone pairs here. So if you ask to determine the number of bonding and non-bonding electrons in this compound, we have the bonding electrons to be 1, 2, 3, 4. So the bonding electrons here is 4. While the non-bonding electron here is, remember that one bonding electron represents one bond, a single bond represents 2 bonding electrons. So 4 times 2 is going to give us 8 bonding electrons in the whole of this compound. 8 bonding electrons, and one low pair represents a pair of non-bonding electrons. So we have 4 non-bonding electrons. So the number of bonding electrons in this compound is 8, and the number of non-bonding electrons in this compound is 4. Take note, each single bond represents 2 bonding electrons. A lone pair represents a pair of non-bonding electrons. Remember, a pair is 2. So that is it for bonding and non-bonding electrons. Now, the next thing I want us to look at briefly is the homologous series. So we are looking at the homologous series. Now, when we talk about homologous series, we are talking about a group of compounds that belong to a particular group. So now we are talking about, let's look into the characteristics of a homologous series. 1, all homologous series has a single general formula. They have a general formula. Let's talk about e.g. alkanes, which has CN H2N plus 2. So this is general. So all homologous series have a general formula. Now, one thing that I also have in common is that each two consecutive homologous series, consecutive members, of a homologous series differ by a CH2 group. Now, what does this mean? Let's say, for example, we have your homologous series methane and ethane, or alkane groups. We have methane and ethane. The difference between a methane and an ethane is 1 carbon and 2 hydrogen. Same thing for alcohol. The difference between 2 consecutive members of the series is a series 2 group, which is 1 carbon and 2 hydrogen. For all homologous series, name them your alkynes, your alkene, and all of them. So this is something you should take note of. Now the third thing that you should take note of is that they have the same way of preparation. They conform to the same way of preparation, but there can be some varying characters in the preparation, but they conform to the same way. There's a single method of preparation for all of them, for all members. And even the reactions that they undergo similar reactions. Now there's something I want you to take us very note down, is that down the group of a particular, of any HS for homologous series, physical properties changes. Now, when you go down the group of any homologous series, you're going to experience changes in physical properties. Now, let's look into some of these changes in physical properties. Now, this is something that you should actually take note of. Some of the changes in physical properties of a homologous series. One thing is that one of the changes that we experience down the group of a homologous series is that they become more condensed. They move from gas to solid. So which means that for any homologous series or any group, the first members of that particular group are always gas. So then when you are going down, it starts changing to liquid, and it starts changing to solid. Now, one more thing you need to understand, that going down a particular homologous series, melting point and boiling point increases. So when you are going down in any homologous series, the melting point and the boiling point increases. Now the other thing is that solubility decreases. So when you are going down any homologous series, solubility decreases. Remember, they become more condensed, moving from gas, liquid to solid. Melting point and boiling point increases. Solubility in water decreases. So these are some of the things you should take note, which means that once you are going down, which means that, let's say for example, a group 5 of the alkene family, let's say for example pentane, is going to have a higher boiling or melting point to the first member, which is methane. Also, when you talk about the one that will be more soluble in water, the first members are more soluble in water than the last members. Then the first members are always from gases to liquid, then the last members are solid because they become more condensed down the groups. So that's all we should be talking about for homologous series. Remember, we have talked about 5 things. We talked about having same general formula, each member differ by a CH2 group, and we also talk about method of preparation. We talked about them having similar reaction type. Then we talked about changes down the group. Now let's look into some homologous series that we know their general formula and the functional group. So let's take a table like this. Let's take name. We're going to look into some things. Gen formula, functional group. Now we're going to look into some of the common homologous series that we know, so that you can always know how to differentiate them. We have our alkanes. Their general formula is CN H2N plus 2, and there's no special functional group. This functional group is your single bond. Now, H2N plus 2. Now, this is how you get the number of any particular alkane. Now, let's say, for example, let me just solve out an example. Let's say we want to determine the structure or the formula of number 5 of this alkane group. Your N begins with represents the number. Let's say your N is CN C5 H2N H 2 times 5, which is 10 plus 2, which will give us C5 H12. Are you getting it? Now, I want to show you something. Okay, I will show you something when I'm done with this. So just have this formula in mind for alkanes. Then we have alkene. Alkenes are CN H2N. That's all. You are not adding anything. The functional group is your double bond. We have alkynes. Alkynes are CN H2N minus 2. The functional group is your triple bond. We have haloalkanes. Haloalkanes are organic compounds that are bonded to halogens. The functional group is the presence of the halogen. Your X represents halogen. Then what else should we talk about? Let's talk about alcohols. Alcohols, you're going to have COH. The formula is you are going to have COH. It's actually CN H2N plus 1 OH. Why the functional group is the OH group. We have carboxylic acids. Carboxylic acids. CN H2N plus 1 COOH. And the functional group is remember we have your three main alkane, and alkyne. Now, instead of going through the first of all, let me write out their molecular general formula. CN H2N plus 2. This is CN H2N. Then this is CN H2N minus 2. Now, N means the number of the particular number of the alkane family you are talking about. Let's say, for example, CN, sorry, this is supposed to be N, not 2. Let's say, for example, we are talking about, you say you should discover, write out the molecular formula of group of the number 5 of the alkane family. It's going to be C5 H2N 2 times 5, 10 plus 2 H12. Then CN H2 times C5 H2 times 5 is going to be H10. CN H2 times 5 minus 2 is going to be C5 H8. Now, there's something I want to let you know. For all these groups, for alkanes, let's say you are given, you are asked to determine the number 7 of alkane. Just do your normal thing. Let's say you have 7 carbon atoms here. Just multiply this by 2, add 2 to it. 7 times 2, 14, plus 2, 16. That gives you the number of hydrogen. So this will be H16. Same thing for here. 6, 7, multiply this by 2 for alkyne. It's going to give you H14. That is the number of hydrogen. 6, 7, multiply this by 2. Multiply this by 2, subtract 2. It will give you 7 times 2, 14, H12. It's just as simple as that. You get, right? Now let me give you a question to solve to see if you really understand what we mean here. Let's say, for example, I give you all this compound C8, H16, C8, H18, C8, H14, and 6, 7, H14. And I ask you to determine which of these belongs to the alkyne family. This is what you do. Remember, alkane is number of carbon times 2 plus 2. So we have this 8 times 2 is 16. So we have 16 here. This should be alkene. 8 times 2, 16 plus 16. This is an alkane. 8 times 2, 16 minus 2. This is an alkyne. So this becomes your answer. So you're going to see so many questions like this. Make sure you don't fuck up. Now let's take one more thing or two more things before we call it a day. Distinguishing factors. Now when we're talking about distinguishing factors, how do you distinguish or differentiate between each groups of organic compounds? Now we're going to distinguish between saturated and unsaturated compounds. Remember, saturated compounds, I told you, compounds with single bond, unsaturated, double or triple bonds. Now the distinguishing factor to distinguish between these compounds is the use of bromine water. Now bromine water, when you pass a saturated compound through bromine water, there's no color change. Saturated shows no color change, while unsaturated shows a reddish brown color. Simple. Now you can also differentiate between saturated aliphatic compound or cyclic compound and unsaturated aliphatic and aromatic. Now this is the distinguishing factor. Saturated aliphatic compound bonds without sooty flame, no sooty flame, while unsaturated aliphatic compound and aromatic compound are the benzene family, bonds with sooty flame. So these are some of the questions that you're going to get. Remember that saturated on bromine water shows no, all saturated compounds on bromine water shows no color change, while saturated compound on bromine water shows reddish brown color. Then saturated aliphatic compound and alicyclic compound bonds with no sooty flame, while unsaturated and aromatic compound bonds with sooty flame. Now let's say, for example, we give you a question like this. Let's say, for example, I give you a question like this. Compound A, B, C, and D were exposed to flame, and we discover that compound A bonds with sooty SF, compound B sooty flame, compound C no sooty flame NSF, compound D no sooty flame NSF. Right? Now compound A on exposure to compound A on exposure to bromine water, shows color change, reddish brown. Compound B, no color change, no CC. Compound C, no CC, no 6C. Now, which of these compound is an unsaturated aliphatic compound? When you remember that aliphatic compound, on exposure to bromine water, unsaturated aliphatic compound, on exposure to bromine water, they show a color change, reddish brown, and they also burn with sooty flame. You will agree with me that A is an unsaturated aliphatic compound. Which one is an aromatic compound? Aromatic compound are compounds that burn with sooty flame, but they don't show any color to bromine water, which means that B is an aromatic compound. Definitely C and D will give us saturated aliphatic compound because they do not show sooty flame and they do not show any color change with bromine water. So I hope you understand this concept about distinguishing factors. Now the last thing I want us to look into before we'll call it a wrap on this particular video is isolation and purification. You know that organic compound will have the gas, will have the solid, and will have the liquid. Now, gaseous aromatic compound, now let's rush this. Gaseous, organic compound, their purification, way of isolation or purification is removal of impurities. So, your method of isolation is to remove impurities that are present in gaseous organic compound. Now we have, for example, your ethene, ENE. Your ethene is passed through potassium hydroxide to remove acidic impurities. To remove acidic impurities of SO2 and CO2. That is for ethene. You remove acidic impurities of SO2 and CO2. Then we'll have ethyne. Ethyne is passed through copper SO4 to remove phosphine impurities. Phosphine impurities. So take note of this, that in the purification of ethene, you pass it through potassium hydroxide to remove acidic impurities, which are SO2, CO2, while ethyne, you remove phosphine impurities by passing it through CuSO4. That is for gaseous organic compound. Let's talk about liquid organic compounds. Okay, we'll talk about gaseous. Remove impurities, remover of impurities. Now, liquid compounds is by crystallization. Sorry, liquid compound is by distillation. So, the method of isolation of liquid compound or purification is by distillation. Now, when you have more like up to 2 liquid compounds that you want to separate, or you want to remove, or you want to isolate organic compounds, you use fractional distillation. Remember, fractional distillation talks about difference in boiling points. So you use fractional distillation. So for solid organic compounds, the method of purification or isolation of solid organic compound is by crystallization. And just like liquid organic compounds, when you have more than 2 solid compounds, you use fractional crystallization. So this is all about this video on organic chemistry. Trust me, this is a complete organic chemistry video, and I prepared another video on organic chemistry questions and answers. So from everything I've taught here, I set a lot of questions and I solved it so that by the time you go into your exam hall, you'll be so familiar with all organic chemistry questions. So the link to that particular videos on organic chemistry questions and answers is going to be on this description, or you can actually search for it after this video, or be on the playlist of organic chemistry. Hope it has been a nice time watching the organic chemistry class. More content and more videos are going to come in after now. I hope you follow us on all social media handles at SPC Tutorials, and also join our Telegram group, our Telegram channel, and our WhatsApp channel. Don't forget, it's Dr. Best and it's SPC Tutorials. Feel free to follow my own personal YouTube page at Dr. Happy Best and other handles on all social media at Dr. Best. Love you. See you next time. God bless you.